Coming up on the Astronomy Show, astrophysicist Sir Martin Rees from Cambridge University tells us about dark matter in the universe. Barry Shanko interviews Dr. John Hutchings about the Hubble telescope repairs in Victoria. And also from Victoria, we take a look at the Hubble archives with Dr. Dennis Crabtree. And of course, Dave Dodge with Astro News. He also has a report on the current meteor that came down in the Okanagan Valley. All this and more on the Astronomy Show.
Hello, I'm Barry Shanko. On this segment of the Astronomy Show, we're going to take a look at how the Hubble Space Telescope has been doing since it was repaired. In December of 1993, the crew of the Space Shuttle Endeavour paid a servicing call on the Hubble Space Telescope. It not only made some equipment repairs to the telescope, but it corrected the faulty optics that were the cause of so much consternation since the telescope was launched in April of 1990. Over at the Dominion Astrophysical Observatory in Victoria, Dr. John Hutchings is not only a staff astronomer at the observatory, but he is a member of the high-resolution spectrograph team, which is one of the key scientific instruments aboard the Hubble telescope. And we'll be asking him a few questions about how the telescope has been doing since it was repaired. Dr. Hutchings, the first question is, how was Hubble doing before it was repaired?
Before it was fixed, we had a lot of different problems with the telescope. There was the optical prescription was wrong, which is the thing that everybody knows about. We also had major problems with the solar arrays, which were flexing very badly during transition from sunlight into shadow when the temperature changed, and these were causing a lot of shake in telescopes, so it was hard to keep it pointed accurately. There were a number of other smaller breakdowns. Gyros had gone, computer boards and other things that needed replacement. More of a routine kind of maintenance thing, but they did have to be repaired.
Now and again, Hubble goes into something called a safe mode. Can you explain a little bit about that?
Every time something goes out of specified limits, and that is, can be hundreds of different conditions on the telescope, there are various shutdowns that occur automatically in order to safeguard the telescope from any possible damage that might be incurred by the malfunction. And there are different levels of safing. So whenever one of these things happens, the telescope automatically takes over, puts itself into some safety kind of situation, turns away from the sun, puts out the solar panels to get maximum power, and then it waits until ground control takes over, and once we've understood what's gone on and know how to proceed from there. There was a safing just about a week ago when the solar panels went out of spec. During some maneuver, one of the torques went over limit and the telescope safed. There is a redundant circuit which controls the safety, which controls the solar panels, and that has kicked in now and is being used on a routine basis. The observations are back to normal, and still there are people trying to figure out what is the problem with the thing that went wrong the first time. As of today, that's not yet fully understood, but it's the sort of thing that happens several times a year, so it's not that unusual.
Are all the scientific instruments aboard Hubble fully functioning?
At this point, yes. We've had almost a year of near-perfect performance on the telescope. We've been actually quite lucky. We expect things to break, and we're planning for replacement of other things in the future, but so far we've had a remarkably trouble-free year since the repair.
What is Hubble able to see now that its vision has been repaired that it wasn't able to beforehand?
Well, the main thing that the fix has achieved is that we have very sharp images now, which means really that we can see fainter objects in more crowded fields, which means really more distantly in the universe, and really we can start to study the kind of research programs that the telescope was designed for. So the image quality has been really the main improvement since the repair.
Could you possibly describe some of Hubble's major discoveries since it's been fixed?
That's a tough question to answer because discoveries sort of imply unexpected things, and really what we're doing is we're proceeding with a lot of carefully planned long-term programs. Some of the earlier results are coming out already, and they've been announced in the press and in the scientific journals. I guess the one that's had a lot of exposure recently has been the determination of the distance scale, or the early results of the program determining the distance scale of the universe. And those were achieved by measuring the brightnesses of very faint stars in distant galaxies. And those indications have given us an answer for one of the numbers that they're looking for. One of the stories about that, of course, is that this early result has given us a new puzzle, because it suggests that on the simple model interpretation of these numbers, the age of the universe is actually a lot lower than the number that we deduced from the ages of some of the oldest stars. So, although there's been an interesting result, it's quite clear that we don't have the final answer yet, and there will be future programs which will investigate and try to sort out some of these questions.
Dr. Hutchings, have you used Hubble yourself since it was fixed, and what were the results?
Yes, I have a number of programs that have continued in the past year, and again, the ones where we've noticed the most interesting changes have been in terms of getting sharp images of very distant objects. So one of the programs I have been pursuing is doing studies of quasars, very distant bright objects in the universe, where we have been trying to find out the structure of material that the quasar, this bright object, lives in. We think there are very faint distant galaxies, and only the Hubble is able to give us some of the details of those structures. Couldn't be seen before the repair, and very difficult to see on the ground. So that's one of the programs that I've been quite excited about.
Are there any plans for new scientific instruments aboard Hubble?
Yes, there are revisits planned for 1997 and again in 1999. In each of those occasions, there will be new instruments installed on the telescope. In 97, there will be a new spectrograph, which is an instrument that I'm also involved in building, and in that same revisit, there will be an infrared camera installed, which will be a new capability of the telescope. In 99, we will be putting in a new camera, which will replace the one that was put in last year in 93. By that time, it'll be 6 years old, and we have new technology and techniques that we hope to be putting in for the camera of 1999. In principle, there's another revisit in the year 02, but at present, we're waiting on budgetary decisions before we know if that'll go ahead.
The defect in the main mirror was taken care of by the optics in the new camera. Is there anything that could be done in the future to make even better gains in performance?
No, actually, the correcting optics that were put in have worked way beyond our expectations. The image quality that we're getting right now from the telescope is design spec. It is the best we can hope for, and we were all absolutely delighted, even amazed when it did work that well. And naturally, any future instruments will have to incorporate the same correcting optics, because it is in the main telescope mirror that the problem arises, and that's not going to change. But we do know the optical prescription very well, and we'll be able to compensate for it in future instruments.
Thank you very much, Dr. Hutchings.
You're welcome.
Not many people know this, but there's only 3 archives of Hubble material in the world. One is at the Hubble Control in Baltimore. The other is at the European Space Agency headquarters in Europe. The third is over in Victoria at the Dominion Astrophysical Observatory. Dr. Dennis Crabtree is the leader of the team that archives Hubble data for all the astronomers in Canada. And this is a special astronomy show look at how this unique facility works.
We have archival data from the Hubble Space Telescope and the Canada, France, Hawaii Telescope. For the Hubble, we're one of 3 archive sites in the world, and for the Canada, France, Hawaii, or CFHT data, we are the only site in the world to have the archival data. And we provide university astronomers in Canada, and in fact around the world, access to this archival data through the internet.
Okay, so if I wanted to get some information, say, on spiral galaxies, I could go into the internet and find this information through you.
That's right. We provide software that people download to their machines, and it would come up look like this. And this is a catalog, this screen contains the catalog information for the Hubble observations. And I could come in here and say I was interested in spiral galaxies, and maybe I was interested in NGC 4321, which is a particular spiral galaxy.
Okay.
So I type in the name of the object here, and then the system connects to another database in France to get the coordinates of that galaxy. I don't remember all these coordinates off the top of my head. And then once we have the coordinates, we can start looking at the catalog to see what observations may exist of that particular galaxy. And as we go through here, we see there's a few observations taken with the with-bit camera before the Hubble was repaired. But I think what's interesting is some of the observations that might have been taken with the repaired camera on the telescope.
So this is what I'd see if I were to log on.
That's
to
right.
the system.
Now I use the analogy of a mail order catalog. So what we're looking at here is the descriptive information. So there might be a little description of this jacket that I'm looking to buy, or in this case, the Hubble Space Telescope data. Now when you look at a mail order catalog, it also comes with pictures. And that's what we've developed as well here, in that besides the descriptive information describing the observation, we have online little images that go along and show the astronomer what the data looks like, to make sure it's the right object, it's high enough quality, it's what he's looking for.
This is basically what we're getting then is the exact image that the Hubble took.
That's right. The astronomer can actually request the actual data. What comes up here in this, what we call preview image, that's not it. What comes up in this preview image is a quick look at the data to see whether it is what he's actually interested in. So we can look at this, play with it, see if there's see if there's a particular star on there that he's interested in. And so he doesn't have to request data, get it sent to him that he finds out later isn't exactly what he wanted. So it's just like a mail order catalog, and then I can request the data, and this is another piece of software that comes along, and this allows me to order it by tape or by electronically over the internet, however I want to get the data.
Okay, so as an amateur astronomer, the best venue for me to find this information would be through my local university.
Internet provider.
Right.
While we basically are here to service professional astronomers, there are other sites on the internet that have available various GIF images and other information and data from other telescopes. So we're sort of geared towards professional astronomers, and but we do have other information available that amateurs can access over the World Wide Web if they wish.
So is this information available now?
Yeah, all public data is available, and if an observation was taken 1 year ago, that's with the Hubble Space Telescope, the data is private for a period of 1 year, and then after that it's publicly available to anybody. So if an observation was taken 1 year ago, that means tomorrow somebody could connect, look at it, and say, okay, send it to me, and we would send it to them.
Okay. Can we go and take a look at some of the hardware behind the system?
Sure, I can show you that in the next room.
Okay. This is the actual storage room, the physical storage room of the data from the Hubble Space Telescope.
That's correct. This is where all the data resides on optical disc. And up here we have all the data from the Hubble Space Telescope. And the total archive is consists of 800 gigabytes of data. And to put that in terms of floppy disk, that's equivalent to 800,000 floppy disks. Each one of these optical disc here holds 6.5 gigabytes, or the equivalent of 6,500 floppy disks.
This is the most modern version of the CD-ROM, I guess you'd call it.
It's like a CD-ROM. It's written with a laser. It's just 12 inches in diameter rather than 5 1/4, and it has a higher storage capacity. Now over here we have the machines that read these.
They're the laser disc player.
That's right.
of
They're
the
the laser disc player, and these two here are the two drives that read those optical discs. And then down here we have the computers that run all this. So this is where we read the data, copy it to tape, and send it off to people.
Okay, so you mentioned before that you could download information from France, like you did it while we were watching.
That's right. All these computers here are connected to the internet. And in fact, what we do now, when people request data, we have to manually come in here and copy it and send it off to them. What we're moving to this year, and we hope to have it finished by the end of the year, is moving the data onto CD-ROM. And what we have here is a jukebox that has a capacity of 500 CD-ROMs, so it's about 350 gigabytes. And what we hope to do in here is copy all the data.
350 gigabytes.
And what we hope to do is copy all this data that we had on the shelf here onto CD-ROM. And what these are all available immediately on the internet. So when people want to get data, we won't have to come in here and copy it for them. They'll be able to click their mouse and download it immediately.
So is this is CD-ROM on there right now?
That's right. This has a capacity of 500 CDs. So there's about 300 empty in here right now that we're going to fill up over the next few months. And then we're bringing in another one of these jukeboxes for a total of 1,000 CDs online.
I can see one of them's being read right now. Is someone using this?
They could be, or they have been. I think they continue spinning even after they finished using them. And there's this black platform down here will come up, select a CD, and go back down and put it in one of the 4 drives. So this is our sort of leading edge technology. We're probably the first ones in Canada to get one of these. And even now at NASA, JPL don't have these yet.
Well, so that's just
You're here.
Yeah. Hope you didn't just make it skip.
Okay.
Will the universe expand forever? Will it eventually recollapse into an enormous big crunch? Today we have a very special guest from Cambridge University in England who's uniquely poised to deal with some of these questions. Sir Martin Rees is probably one of the most prominent astrophysicists in the world today. He deals with every scale of astronomy that one can conceive of, from cosmology, sizes of billions of light years, the entire scope of the universe, down to black holes, which in a physical sense have zero size.
Now, my subject is a big one because, as I'm sure everyone knows, dark matter is between 90 and 99% of everything in the universe. And I want to talk about how we know about this mass and what it might be. Well, the universe is expanding, but the expansion is being slowed down because everything exerts a gravitational pull on everything else. And if there was enough matter in the universe, including the dark matter, then the expansion would eventually stop. It turns out that the amount of matter you need is very low. It only requires about 3 atoms in every cubic meter. That doesn't sound very much, but that's about 50 times more than the mass we actually see in all the stars and all the galaxies. But if there was enough dark matter to make up that difference, then eventually the universe would stop expanding and the galaxies, which are now receding from each other, would start falling together again. They'd display blue shifts, they'd get brighter, they'd merge with each other, and eventually everything would collapse in what some people call a big crunch, which is rather like the Big Bang which set the universe expanding. But it's reassuring that the big crunch can happen at the earliest 100 billion years from now. So it's not an immediate worry. In fact, long before that happens, the sun itself will have died out and flared up and destroyed and vaporized the Earth. That's going to happen in 5 billion years. And so astronomers are used to thinking on these much longer time scales when they talk about the future fate of the universe. So these are the 2 possible candidates, either very low mass stars or black hole remnants in the mass range 1,000 to 1 million solar masses.
How long do you think we're going to have to wait for a clearer answer to the nature of dark matter?
Well, I think what's encouraging is that there are lots of different lines of attack being used by astronomers and physicists to tell us what the dark matter is and what it can't be. And so I'd be fairly confident that if you asked me this question a few years from now, I'd be able to give you a far more confident forecast for the next 100 billion years than I can now. So I think we will have a clearer idea of how much dark matter there is and what the fate of the universe is likely to be within a few years.
Well, we'd certainly love to have you back here in Vancouver in a few years and deliver another series of excellent lectures. Thank you for taking out time to speak to us today.
Thank you very much.
Welcome back to this month's edition of Astro News. I'm David Dodge. As usual, we'll start off with the phases of the moon. New moon was on the 1st. First quarter will be on the 9th, Full moon on the 16th, last quarter on the 23rd, and a second new moon on the 30th.
Well, last month we showed you how to find Orion the Hunter, and it was due south around broadcast time. But now if you go out looking for Orion, you'll see that it's further along in the west. This is because the Earth has moved further along in its orbit around the Sun, causing all the stars and everything else to move further along the west at any given time. This also means that Mars is higher in the sky at broadcast time. Last month, if you went out to find Mars and noted its position amongst the background stars of Leo the Lion, take a look at it tonight and notice how much it's moved against those stars. Because the Earth moves around in its orbit, it causes the Sun to shift its apparent position on a day-by-day basis. And right now, the Sun appears to be moving northward. On March the 20th, at 18:17 Pacific time, or 21:17 Eastern time, the Sun appears to cross the Earth's equator, and that is the beginning of spring. This also means that if you are watching Venus in the morning skies these days, you'll have to get up even earlier to catch her before morning twilight gets too bright. Many cultures use the phases of the moon to mark their religious celebrations. For example, this past new moon is the end of Ramadan, the high holy month of Islam. The upcoming full moon is used in conjunction with the spring equinox to mark the date of Easter. The Easter is the first Sunday following the first full moon following the spring equinox. Well, the equinox is on the 20th and the full moon is on the 16th, so we will have to wait to the next full moon, the 15th of April, before we can mark the Easter Sunday, which of course is the next day, the 16th of April. Speaking of April, don't forget to move your clocks forward at 2 o'clock in the morning on April the 2nd. Last Monday, February the 20th at 9:12 p.m., Vancouverites were treated to a spectacular meteor crossing the eastern sky. This spectacular meteor, or more precisely called a fireball, was seen as far away as Port Alberni on Vancouver Island, Prince George in north-central British Columbia, and as far south and east as Flyhead Lake in Montana. The H.R. McMillan Planetarium in Vancouver, the Dominion Astrophysical Observatory in Victoria, the Clemenhaga Observatory at the University of Victoria all received hundreds of phone calls about this fireball. And we can now put it all together and give you a profile of the flight path of this rock. At 9:12 p.m. on the evening of February the 20th, a rock entered the Earth's atmosphere just east of Williams Lake. It flew directly over Kamloops and went down the Okanagan Valley and exploded just over Karameas. By analyzing the flight path, Chris Aikman at the Dominion Astrophysical Observatory has been able to suggest with a reasonable amount of certainty that some of this rock may have come to Earth. And if it did in the US of A near Oroville, Washington. Now, if this happens again, if we see a fireball, I'd like you to remember what I showed you last year about how to measure things in space. Take out that yardstick you've all got at the end of your wrist, a clenched fist. That covers 10 degrees. Measure how high above the horizon the fireball was when you first saw it in clenched fists, how far along the horizon it was as using the compass rose, with north being 0, east being 90, south being 180, and west being 270 degrees. Measure how high above the horizon in fist distances it was when it ended. Note any spectacular colors or sounds that you may have noticed, and above all, note the time to the nearest minute. If you can do all of that and phone us about what you saw, then you've provided an astronomer with a great deal of information. Well, that's the Astro Lecture for tonight. We'll see you next month on the Astronomy Show. I'm David Dodge.
The last few years have been exciting times for those who study the smaller objects in the solar system, and you're generally on top of that kind of study. You've done some of the best research yourself. What do you feel is the most surprising thing you've learned about asteroids or comets in the last few years?
Well, the surprising simple thing is that we found a moon around asteroid Ida. It's a thing about 1.5 kilometers across, a small little thing, and I think that's a surprise to many people. First moon found around an asteroid. Perhaps the more important thing we're not quite so sure of yet, but it's beginning to look like the asteroid Ida is got a composition and has modification processes going on its surface that could mean that it and other asteroids like it are the parent bodies of the most common meteorites that fall on Earth, the ordinary chondrites. And it's been a big mystery for several decades about where the most common meteorites in the solar system or on the planet Earth come from. And there's a class of asteroid out there called the S-class, and Ida is one of them. And most of the experts have said, no, the ordinary chondrites have spectra that don't look like the S-type asteroids. But our photographs of Ida show that there's a color modification process that changes the spectrum with time. Fresh craters, things that are very sharp and were made recently, have a different color than those that are older. So the colors are changing, and the nature of the changes is such that I think we may have unlocked the key to where these meteorites are coming from. And that's pretty interesting to those of us who look up at the sky and see things falling down on us from time to time.
I know that had been a profound mystery as to why we can detect things with spectroscopy among the asteroids that don't seem to match what we pick up off the ground. And it looks like a sort of weathering phenomenon, you think, in space, which is a curious concept in itself.
It's a curious concept, and exactly what this weathering process is, we don't really know yet, but we now can say it must be happening. We can see it happening on the surface of Ida.
Have we got a real handle on the asteroids yet? There's a big batch of them in the gulf between the orbits of Mars and Jupiter. There are a few in the inner solar system that sometimes give an exciting time to the planet Earth. We can't see such small objects too much farther out in the solar system. Is there a lot out there waiting to be discovered, do you think?
The more we push down the detection limits, the more we see. The shoemakers have been doing surveys other than hunting for near-Earth asteroids, and they have found that the Trojans that orbit the Sun in Jupiter's orbit, 60 degrees away from Jupiter, constitute an asteroid belt about half as big as the main asteroid belt. In other words, there's a comparable number of Trojans as there are main belt asteroids. And of course, far out in the solar system, we're finding these proto-comets, the trans-Neptunian objects of the Kuiper belt, as it's called. So wherever we look in the solar system with more sensitivity, we seem to find some things.
There's lots more out there, you think?
I'm sure, particularly small ones.
All right. If a breakthrough happens next week, and we're going to be sending a mission with a human crew to one of the nearer asteroids, and you get selected to be on it, what measurements would you like to take?
Oh, I don't think I'd want to go on a mission to an asteroid. I'm happy right down here on the Earth.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver. We want to hear from you.